Hello friends, welcome back to the bench. Our patient is a ASRock B650 for the socket replacement, and this is a very nice board which doesn't look like much when you look at it comparing to other high-end boards. This one has very few heat sinks. It doesn't look like much because of that. Typically, especially in Gigabyte and Asus, they come with this whole plate in the back, the aluminum plate, which not only dissipates heat but also protects the back of the board, so they're a lot more sturdy, a lot heavier. But it accepts a DDR5 memory, which is awesome. Here we got DDR5, 4 slots. Needs to be cleaned, but that's fine. We have 3 M.2 slots. This one is Hyper M.2. I'm not sure what the difference is. And we can put M.2 Wi-Fi on it as well. I'm not sure why it's crooked a little bit, but that might be fine. Maybe that's the feature, not a bug. We have on vCore, we have dedicated drivers, which is, it's easier to repair the board that uses transistors instead of drivers. Because for the most board, for the 99% cases, you can just replace that transistor with any other transistor from any other board, with some exceptions obviously, and as long as it's the same kind, N channel or P channel. But we have 2 8-pin connectors for vCore, so this board can pull some serious CPUs. And standard ATX connector, not extended. So not a huge, maybe not very powerful, but powerful enough. And that's pretty much it. In addition to four SATA ports on it, obviously 2 PCI Express, 1 full size and 1 looks like half size, which can pull also pretty serious graphics adapters. As far as IOs, it's nothing to write home about. But we do have the network adapter for the cable, and obviously we can connect the wireless directly to the board. We have 1 USB-C, no optic output for the sound, HDMI for the display, but obviously you probably don't want to use the internal one. You want to put some serious GPU on it. This can hold. This can pull probably a pretty good GPU. And there we have holes for the antennae for the wireless, so the cables would go through here, and you can put 2 antennae on the back of the board. Quite a few USB Type A's and the BIOS reflash button, which is good because the BIOS chip is one of those that you find on the laptops, so it's next to impossible to clip on these ones, or at least I haven't had any luck trying to clip on these ones, so I would probably desolder it to reflash it, but you can also use this connector over here to reflash the BIOS in circuit without removing it. But the removal and resoldering of these chips is not a big deal. And that is pretty much it. The socket is AM5, and after my modifications to the IR6500 rework station, this is going to be the first AM5 socket that I'm going to be replacing on. So let's see how it goes. So obviously step 1 is to remove all the heat sinks and everything that is heavy on the board, both to minimize the deformation of the board and to reduce the amount of heat that's going to be eaten by those heat sinks. Now with the modification I made to the bottom heater, the thermocouple now reads the temperature of the board, not the temperature of the heater, which allows me to heat the board up to roughly 105 degrees, maybe 110, and I set 130 and even 120 on the bottom heater now, and that gives me a very nice temperature of the board, so the whole process is a lot easier now. Also, the entire board heats up rather uniformly. It's not only the part that we're preheating, it's the entire board now without that glass on the bottom heater. That made a big difference. Now I'm placing the CPU socket exactly in the center. The distance between the top heater and the board is 3 centimeters. I'd like to keep it at the same height because the distance makes a big difference. Now that turned out to be not the good thing as far as placing the socket exactly in the center. For this particular heater, for some reason the top of the socket heats up, doesn't heat up basically. So as I desoldered the socket, the bottom side of the socket desoldered immediately, or as expected, while the top was still holding. And what I had to do is move the board a little bit, moving the socket effectively a little bit closer to myself, so offsetting it from the center, and that released the socket. And that was the same problem when I was resoldering the socket. After the whole procedure, I noticed that the top of the socket had some play. The top half of the socket, pretty much the entire top half, did not solder on. The solder did not melt. Now we're still in the preheating stage. The board will reach roughly 90 degrees before I start the actual program. The actual program is pretty much the same as I used for 1151 and 1200 socket, but AM5 socket requires slightly higher temperature. So the modification I did was, still we're heating up to 160 for 2 minutes, then 225, and in this case you'll see that it's 225 for 2 minutes, and then 230 for 100 seconds. But that is not enough. Now here we're desoldering the socket, so it's the procedure is slightly different, but that gives you a good, when you remove the socket and your program doesn't seem to want to let loose, right? The socket doesn't let loose. As you can see over here, 225 doesn't even make a dent. As it switches to 230, the bottom of the socket definitely did desolder and it was ready to be pulled, but the top wouldn't let go. For these sockets, 235 is more appropriate temperature, and as you can see I now upped it to 235. But that was not it. That was not the whole thing, because now again the bottom is letting loose, but the top won't. So as you can see, I had to move the entire board, and just as I moved it, the socket let loose perfectly. No ripped pads, no deformation on the board. Pretty much what you want to see. But for that reason, you have to remember that when you're resoldering the socket, you have to move it a little bit closer to yourself, a little bit closer to the front. Now, to save on the wick and a flux, what I do is I just push all that raw solder without mixing it with anything, just push it off to the sides. Just push it off the socket and then remove it with the tweezers. Just form a big blobs and remove them with the tweezers. Now, as you can see, sometimes it's very easy to remove those blobs, and sometimes they hold a lot stronger. So definitely don't fight with them, because you don't want to damage the board. This is just to make it easier, not to make it harder. If it doesn't let go, leave it be. You can remove it with soldering iron. Don't fight with it. Now, I used NC559 flux, which is recommended by a lot of you guys. Now, the reason I use it here, as I said, it's the RMA flux is a lot better for this purpose. It works a lot better. It requires a lot less time, and the solder cleans very nicely. The socket is perfectly clean. Now, with this NC flux, it takes a little longer. You have to do quite a few more passes. But the reason I use this one is basically RMA flux is very toxic. It smells really bad, and you don't necessarily want to breathe those fumes. Even with a good fume extractor, you're still gonna have some of that. So I use NC flux whenever I can, just to reduce my exposure to harsh chemicals. It also smells a lot better, so it's a little more pleasant. But for resoldering, I use RMA flux. It's nice and clean. Now, some of these blobs left behind I remove with a plastic spudger. I left some of them, but I will clean them afterwards. Okay, so the socket is replaced. It required a little bit higher temperature than I use on 1151 and 1200, basically those sockets with window. The issue with my method of saving time and saving flux and saving wick, as you can see, I have some solder left over here, so that needs to be cleaned. See those little pieces of solder. Now I use plastic spudger, and that usually works perfectly fine. Now you don't want to fight with it too much. If it doesn't want to get off, like this one. Yeah, oh, and now it did. But if it doesn't want to release, then don't fight with it too much. Just heat it up. If anything, you can just use the soldering iron tip to just kind of change its shape, so there's less surface contact, so it'll release. And in some cases, if you drop the temperature on the soldering iron, it'll become more sticky, and you might be able to pick it up with the soldering iron tip. But as you can see, the plastic spudger can also pick it up. And obviously we need to clean it. The only risk with this is obviously you don't want to damage the board when collecting solder over here, right? There's another piece that doesn't want to get off, so I might reheat it. But first I'm gonna clean it with a alcohol and toothbrush. There was a sticker over here which I didn't notice. and it was underneath the aluminum foil. So yeah, I should have removed the sticker before the procedure, but it looks like it's coming off cleanly, so it should be fine. There. Yeah. And just some alcohol and toothbrush. I don't see any damage, but again, it's a little bit risky. It saves you, definitely saves you a lot of flux. It saves you a lot of wick, because that's a lot of solder. The other trick that I use is I mix it with leaded solder, and I put a lot of flux, then work with the soldering iron, and it forms nice blob. As long as you have a lot of flux, even the NC flux, it forms a very nice bubble, and then you can move it aside and pick it up with tweezers. In this case, I didn't use either flux or leaded solder, so the blobs were various shapes, and it's a little more difficult, but you know, it's kind of a trade-off. If you want to do this a lot, you gotta find some ways to just kind of stretch your tools, stretch your equipment and supplies to last a little longer. If you use the entire wick for each job, yeah, maybe the wicks are not too expensive, say $5, $7, maybe $8 a piece, but you know, it all adds up. So it's better if you don't need to use the wick, don't use it. And that is pretty much it. The board is ready as far as the socket replacement, so just some cleaning and we should be good to go. The socket is sitting nicely. I actually used the like kind of a manual heating because I wasn't sure. It didn't look like it dropped, but it's very difficult to see when it dropped on these sockets because they're always a little bit lifted off the board. It's a lot more prominent on 1200 and 1151 sockets. AM5 doesn't really look that doesn't really look like when it drops that it did drop. But as you can see, it's perfectly aligned. That is one thing that now I managed to get pretty much every time. And I don't really have any advice when it comes to aligning. I know I had a lot of issues with aligning at the beginning, and it just came with experience. Just keep doing it, keep failing, and eventually you're gonna start succeeding. That's the best advice I can give you. As far as the alignment tools and stuff, I'm not sure if there is anything that will will be super beneficial to make this easy, because then even after you put the alignment tool, put the socket, then you have to remove the alignment tool, and while removing the alignment tool you might move the socket. So I think it's better to just learn how to align them by looking at them. And what's very helpful in that process is the light. Just use the light in various angles, so you can see on the left, on the right, top, bottom. And then obviously try not to move the board during the procedure so the socket doesn't move, which is a little harder with hot air. It's a little easier with IR, but nevertheless, in both cases, it's it's a pain. But just keep doing it and it becomes easier as we go. Alrighty, I think that'll do. We'll send the board back for testing, and we'll see if the procedure was successful and whether the socket was the only issue with this board. If not, then, well, what are you gonna do? You can't win them all. The original socket actually only had a few pins bent, and I think one is broken in the corner over here. Not sure what those pins were, whether they were Yeah, that looks like there's like at least 2 of the pins missing. Maybe they were redundant, maybe it worked before, but in either case, it's a good rule to have. Once the socket is damaged, you don't test the CPUs on it. You don't test the board until you replace the socket. Alrighty, that will do. Thank you guys very much for watching. I do appreciate you, and I shall see you in the next one.